Recording is rolling. It is Thursday, February 22nd. We're going to go over these solutions that you guys have been working on the last couple of days, SAT. So, got to keep kind of a fast pace. I should be able to finish maybe section 3 today, possibly. And then if you have any questions about the way I explain something, then please ask though, and maybe I'll explain it a little bit different way. All of these, I'll try to find what I think is like a good way to solve it. There might be multiple ways to think about some of these questions. Okay. Also, guys, notice you guys see on the first page they give you some geometry formulas. You guys see that? Areas of different shapes, or volumes of different 3D objects. There's a question you guys got about a cone. You guys see this cone right here? Right. Let's look at this cone real fast because this is going to come up later. Right. The volume of a cone, 1/3 pi r squared h. Right. Now, I mean, I guess you could memorize it or just reference it if you guys get a question about a cone, right? But you know what? Look at this pyramid too, right? This cone and this pyramid. See how they both have some area base and they come to a single point, right? And look, ooh, they both have a 1/3 factor. So let's break this down. Pi r squared could be the area of that circle, or for this pyramid, length times width could be the area of that base, right? Then multiply by some height. Now, guys, if you just have base times height, that would turn this picture here into a cylinder, or this picture on the right into just a basic box, right? But okay, that looks like these formulas just without the 1/3, right? But the fact that they come to a single point, that's where anything comes to a point, you just throw in the 1/3 factor, okay? Right. Maybe help you think about so it's a lot more easily memorizable because you know how that works, right? Right. First question: what are the solutions to the quadratic equation? And they go, oh, look at that right there, right? Which, by the way, if you graph that, would be a parabola, wouldn't it? Like a parabola, right? So they say equals 0. Now, I'm going to change this a little bit. I'm going to say y equals. Now, they didn't say y equals, but I'm going to say that. Think of it like a parabola, right? 3x squared minus 3x plus 18. Now, they did say equals 0, right? So, maybe we want to factor. Hey, I see 3 terms that all have multiple of 3. Can I pull a 3 out? I'll do maybe one better than that. I'll pull a -3 out. -3. That will look like x squared plus x minus 6, I think. Is that what that is? Did I do that right? I think. Okay. Catch me if I make a mistake somewhere. Does this look like it wants to be factored? To anthropomorphize this math. Where two numbers that multiply to -6 and add up to +1. You guys think +3 minus 2? I think that would work, right? Let's double check that. FOIL. So I'm going to do foiling to check my factorization. That worked, right? First, x times x squared, bing, outside, inside, -2x, 3x. Add that up together. Gives you x, bing, 3 times -2, -6, bing. Yeah, it checks out. This is the correct factorization. Okay? Now, why did I do all that? Guys, look up here. Guys, taking some notes. Taking some notes. Paper for some notes. Note time. The advantage of having it in this form is that now they have a bunch of things that are multiplied together instead of added together like it was originally given. Right? If any one part is 0, the whole thing is 0. Because it says equals 0. So if this is 0, that will give me a solution. If this part's 0, that will give me a solution. Right? So x could be equal to what? -3 or +2. Right? Those are the 2 answers. Right? So that is option A. Is that? Right. I got the answer key next to me here. Yeah. Number 1 is A. Number 1 is A. You guys score yourselves. Right. Score yourself as we go along. Right. Score yourself as we go along. See how you do. You guys should have here just for video. For the video, you guys are keeping score on this paper here. Okay. So you're gonna see we're on section 3. Number 2. Which of the following could be an equation for line M? Right. So there are different ways to write equations of lines. There's like standard form and slope-intercept form. No, I'm more familiar with slope-intercept. I use that all the time. We use that all the time in this class, right? Y equals mx plus b. So what I would do if I see a question like this is to solve this in terms of slope-intercept. And then if you had to translate it to any other form, you could do that after the fact. Okay. So I'm going to say y equals mx plus b. And then feed in the different parts. Okay. So M got the slope, rise over run. If there's some guy walking up a really steep mountain, or maybe like a mountain goat, goes rise over run, that's what over what? Up 2 over 1. I said See, it's going up 2 over 1. Right, that's like this number right here. Right? So 2x plus, and then what's the y-intercept? -2. Right? Right? This equation right here will describe every single point on that line. Right? For example, what if I pick this random point right here? This is the point 3, 4. You guys see over 3 up 4 from the origin, right? So if I plug in 3 for x, I should get 4 for y. Let's see if it does. Okay? Plug in 3 for x. 2 times 3 is 6. Minus 2 is 4. Yeah, and that would be true of every single point on that line. Okay. Okay. Now, is there an answer choice that looks like that? There is, and it's option C. Number 2 is C. You guys got 2C, right? And if they put it in standard form or something crazy, you could just algebraically rearrange that. Okay, you guys good? Number 3, the circle above with center C has an area of 48 units. Maybe it's like 48 square meters or something. What is the area of the sector MN, which is shown to have a 60-degree angle? Ooh, 60 degree. Hey, and the full circle, how many degrees all the way around? 360. Right? What fraction of that does 60 degrees represent? 1/6, right? 1/6, right? Do you guys think if you had a big old pizza and you cut off a 60-degree slice, you could get 6 slices out of that? You guys think? Right. You guys ever played a game called Trivial Pursuit, maybe? Yeah, they give you little game pieces. Look like you get little wedges with 60 degrees. Ah, look at that. Trivial Pursuit. Okay, so this is 1/6 of the whole circle. If the full circle is 48 units, what is 1/6 of that? 8. 48 divided by 6 is 8. D. Number 3 is D. The answer is D. You guys got that? Okay. Number 3 is D. D. Because 1/6 of the full 48 is 8. Okay. 48 divided by 6. Okay. Number 4. Which of the following is equivalent to the sum of these two expressions? We got x squared plus x and negative x minus 2. All right, well, you can add like terms. There's only one x squared. So there's an x squared. So jot that down, which, by the way, just narrows it down immediately to option C. Right? I see a plus x and a minus x, which cancel out. And I see a minus 2, which is going to also show up in the answer. So should it be just x squared minus 2? You guys say the answer is C? Right. Number 4 is C. You guys got number 4 is C? Number 4 is C? Are we good? Right. Right. You guys good so far? Right. If you guys have any questions, then ask me. I can write some down later. Number 5. Which of the following cannot be an example? Okay, so we're looking for like a negative. It's framed in terms, right? Cannot be example of a function whose graph in the xy plane has 2 x-intercepts. Right? If I glance through all the answer choices, see how it talks about zeros, like real zeros, something like that. You guys do know that is a synonym for x-intercepts, right? When you just mathematically, okay? So maybe a definition kind of question. Okay. So I do want to make graphs of these, so you guys have a picture going. Option A says a function with an absolute value and real zeros. Guys, what do absolute value graphs look like? What? Yeah, like V's. Yeah, yeah. So if you ever see like a V type graph, I bet you could express that in terms of some kind of absolute value, kind of shift it around like a V shape, right? Right. And the application here is real zeros means right there and there. Ah, those are x-intercepts. Right. Okay, so that would not be the answer we're looking for, right? Because that's an example of something that does work. We're looking for the not. Option B, a cubic polynomial with only real zeros. Now, a cubic polynomial, let's just get a bunch of graphs going here, a bunch of axes. Boink, boink. Lots of graphs. Graph and Griffin. Okay, a cubic, could that look like maybe some version of this possibly, right? Is maybe one example, right? And I drew this in such a way that it has these 2 zeros, the 2 real intercepts. Okay, okay. Right, so that one is cleared. I'm not going to choose that. Right? Now, option C and D both say quadratic function. C says with real zeros. Option D says with no real zeros. So here could be option C, and here could be option D. Right? Okay, you guys see option C and option D? Right? Option C has point, point, and option D has no real zeros. Okay? Right. You guys get there? So option D is the one we're going for. Right? Now, why does it say real? That would be in contrast to what other kind of zeros could have if they're not real. Imaginary. Ah, right. So this parabola that So it doesn't touch the x-axis. There's no x-intercepts. Well, there are imaginary answers, right? Which crazily enough has some real-world solutions too. But right, so we're looking for. Did I say 5 is D? I said, yeah, 5 is D. Right, 5 is D. All right, number 6. Square root c minus 1, and then outside the root minus t is equal to 0. Right. When you guys are writing this in your own handwriting, make sure when you're writing square roots to extend the bar exactly over what's being square rooted, right? You see printed here, right? T is 4. What is C? Let's solve it. So square root C we're solving for minus 1, and then outside the radical minus 4 is 0. This is all for 6. Right. Okay, guys, what should I do first? Should I square both sides first, or should I add the 4 over first? Add the 4 over. All right. Here's why. Okay. Because if you square both sides first, you'd end up with a crazy FOIL situation, FOIL. There would still be square roots, and it would just be messier. You'd be going the wrong direction. Yeah. So add the 4 over first. Now you can square both sides. The radical very nicely goes away. Should it look like that? Do you guys think? Okay. And now add the 1 over 17. There's your answer right there. All right, guys got that? Oh, and what letters? The option A is 6A. Let me check. Yeah, 6 is A. 6 is A. All right, you guys got A on 6. Number 7. Ooh, what is this? X is y squared. Now pause right there. X equals y squared. If you graph that, what shape would that make? A sideways parabola. That's a sideways parabola, isn't it? Right? Not technically a function. It failed a function test, right? But it would be a sideways parabola. And the second equation, I see an x and a y. What shape graph do you think that would make? Straight line. That is a straight line. And you know that because the x and the y each have just a power of 1. Right, so somehow you could turn this into y equals mx plus b. You take a bunch of rearranging. Right? So there's some xy solution to these two equations, and y. So for y being negative, what would be x times y? Okay. So there's a bunch of little steps to this one, bunch of little steps. You one at a time, right? By the way, a sideways parabola in a straight line might possibly intersect at 2 places, which in this case it does, right? Might brush up at one single point like a tangent line, or the line might miss the parabola entirely, right? So what do we here? I'm going to solve this by substitution. I'm going to take y squared and substitute it in for that x right there, okay? And solve this by substitution, right? So 6 times. But instead of x, I'm just going to go ahead and call it y squared, because x is y squared. Okay? And then plus 9 is equal to, and I'll distribute this part too. 3 times 2y, that's negative 6y. And then negative 3 times negative 3 is positive 9. Okay, is that okay? All right, did that substitution, that distribution? Okay. Right. Maybe I'll just kind of proper math way. I'm going to add 6y over 6y squared plus 6y is 0. Kind of factor out a 6y. That gives me y plus 1 equals 0. Okay, guys good so far? Right. And why did I do it like that? Because now I have things that are multiplied to 0. And just like a few questions ago, if either part 0, the whole thing's 0. So y could be 0, y could be negative 1. Okay, those are, well, the y values of the 2 solutions. Okay, right, guys good? Okay. No, we're not done yet, but that was the first part, right? Because they said, what is x times y? Okay, so we got to go back and figure out what is x, right? Now, I think the fastest way is to look at the first equation. X is y squared. If x is y squared, right, then, well, 0 squared is 0. Negative 1, guys, what is negative 1 squared? You got positive 1. So now we're getting these 2 coordinates. 0, 0 is a solution. Negative 1, positive 1 is also a solution, right? Is that true? Right. They did say hone in on the negative value for y. Y is negative. Okay, that's what that says. Okay. Right. Now we're getting to the final leg of this race. What is x times y? So x times y, that gives you what? Negative 1, which is option B. Let me confirm, is 7B. Yeah, 7 is B. 7 is B. You guys got 7B? Right, you guys good there? Right. Here's one more thing I want to do with this. I want to graph this. Let's graph it. Because I know those are the 2 solutions, and I know what basic shape this looks like. These graphs look like x, y. So I got negative 1 What happened? Oh, did I? No, I messed that up. Oops. Right, that's okay. The answer is still whatever I told you it was. Right? I got that backwards. Okay. So sorry. Y is -1. Square that, you get x is +1. Oops. Okay. So we got 1, -1, and we got 0, 0. So it's like 1, -1 could be like right there, bam, and 0, 0, bam. Now that's the two places these graphs cross, right? Okay, you guys get that? Right. Now x equals y squared looks like this, or you can say y equals square root of x, plus or minus, right? Right. There's the sideways parabola, right? And oh, this right here must be the straight line. So that's the graph version of that same question. Okay. Right, guys good? All right. Yeah, so 7 is B. Number 8, Richard either walks or rides his bicycle everywhere he goes. Up the stairs in a boat with the goat. When he walks, he burns 50 calories per mile. When he rides his bike, 25 calories per mile. I think it makes sense, right? Richard can travel no more than 15 miles per day, but he wants to burn at least 500 calories per day. You see a conundrum being set up? Right? He wants to burn so many calories, but he's restricted to how far he can go. Right? Like if he bikes everywhere, let's see what would happen if he biked everywhere. Right? He's biking everywhere, up the stairs, in a boat. He's going 25 calories per mile for 15 miles. That would only bring him up to 375 calories, which is not his goal. Right? Okay. So I'm just thinking about little extras. Which of the following systems of inequalities represents the situation in terms of W and B? Number of miles walked, number of miles biked. Right? So they don't even want you to solve this. They just want to say, can you translate this scenario into math? Right? You guys get that? Right, so let's check out the answers. What does option A say? Let's check out. So 50 calories per mile times the number of miles walked plus 25 calories per mile times the number of miles biked. Okay, so that, okay, so far is less than 500? Oh, hold on a minute. He wants to burn at least 500, which could be 500 or more, right? Like 600 would be okay, 700 would be okay, but not 400. So I think this is almost all right, except that inequality is backwards. You guys see that? Inequality is backwards. He wants more than 500, not less than 500. Okay? Now, let's check out the other one. W plus B, so walking plus biking, can only go up to 15 miles. No, that actually is true, right? It's okay if he only goes 10 or 11 or 12 or 13. He can't do 16 or 17 miles, right? So this one's okay. This one, the inequality is backwards. Let's say option B. You guys like option B? Right, because that one gets everything exactly correct. The inequalities are the correct directions. Is 8B? Let me check. Yeah, 8 is B. 8 is B. You guys got 8 is B? You guys grading yourselves? We're going along. Okay, 8 is B. Number 9. Rankine scale is alternate scale for measuring temperature where unit of temperature is Rankine, right? Ooh, you guys remember this class a few weeks ago? I showed you guys different temperature scales. We didn't actually do this scale, but I guess it could be like a 4 scale, right? The conversion from Celsius to Rankine is given by this function. So the temperature in Rankine is 1.8 times the temperature in Celsius plus, and I'm just going to call this number 491. Okay, right? Which is the side thought. Right. Guys, 1.8. What is that as a fraction? Is that 9/5? 9/5, right? 18 over 10, 9/5, right? Which should look familiar because that's the translation from Celsius to Fahrenheit, right? I think what this system is sort of an absolute scale, kind of like Kelvin was, except it's scaled according to Fahrenheit. I think that's what this is, right? That makes sense, right? Right. Which of the following statements is the best interpretation of the number 491 in this context? Okay, so say what does that mean? Right, and I think the best way to handle this is I would say I would come up with an answer in my head what that could represent, and then I would hunt for an answer choice that's closest to that. So what if this looks a lot like y equals mx plus b, doesn't it? Y equals mx plus b. Right, there's a translation from two temperature scales, kind of like from Celsius to Kelvin, except we're on Rankine. Right. What if the temperature in Celsius was 0 degrees? So like the freezing point of water, right? In that case, the temperature in the Rankine would be 491, wouldn't it? Right. So see, that would be the temperature at the freezing point of water, right? Would be one way to interpret that, like an intercept kind of thing, right? Right. All right, so let's check out their answer choices. Option A, the increase in Rankine that corresponds to a 1 degree increase in Celsius. Ooh. That's not the 491. but that does answer a different question. Guys, option A would have been the answer to what question? Maybe it's like a Jeopardy kind of setup. What is 1.8? Ah, all right, Jeopardy winner here. That's it, right? If they replace this with 1.8, well, what does 1.8 represent? The answer would have been option A, right? Because it's like that scale and change. Ah, okay. Right. Option B, the increase in Rankine that corresponds to a 1.8 degree Celsius increase in temperature. That is not anything. That is a junk answer. Option C, the temperature increase. Here's why. Because if you popped in 1.8 for that Celsius, now you're multiplying 1.8 times 1.8. Okay, this is total junk. Right? The temperature in degrees Rankine at 1.8 degrees Celsius. Again, you plug in 1.8 degrees Celsius, you get like almost 500. So that's junk too. Option D, the temperature in degrees Rankine at 0 degrees Celsius. That's exactly. Oh yeah, right. Because you plug in 0 here, you get 491. Boom. Right. D. 9 is D. You guys got 9 is D. Yeah. High five. Ooh, on second try. Which of the following is equivalent to 4 to the power of 5 over 6? All right. And if you, this one's a little bit tough. Oh, okay, I threw it, of course. Right. If you glance down at the answer choices, okay, I see some radicals going on. I see some 4s. Ooh, I see a 2 there, which might be a hint about how they want you to go about solving this. So I'll walk you guys through one way I might do this. This is going to be a lot of steps, but here's what I do. So 4 to the power of 5 over 6. We need to re-express this to get something to do with the radical and possibly a 2, maybe. Okay, so maybe I'll make that substitution. Can I express 4 as 2 to the power of 2? Okay, let me go do that. I'm going to substitute in for 4, 2 squared, because that's what 4 is. And that's still to the 5 over 6. Right. Now I have a power to a power. I think the premise of this question is, do you understand power math? Right? What do you do to a power to a power? Do you add or multiply those two numbers? Multiply. Right? Could that be 10 over 6? Does that reduce to what? 5 over 3, right? Right. Now that's an improper fraction. Oh, could I do something like this? 3 over 3 plus 2 over 3. Can I do that? Is that right? Same thing, right? Right. And then 3 over 3, that's like 1. That's like 2 to the power of 1. Right. Now I'm like multiplying 2 to the 1 times 2 to the 2 over 3. Yes, that's the same thing. Right? No. Okay. And then, okay, so that's just 2, right? Oh, ooh, could I re-express this like as a radical? Like the cube root of 2, right? So 2 times, yeah, the cube root of 2 squared, right? So that might be good, except I think I could do one more thing. 2 squared, can I turn that back into a 4? Right, 2 times the cube root of 4. There you go. So let me zoom out. You guys can see the whole thing. Woo! That was a lot of steps. Right, but I think that's what they're looking for. 2 times the cube root of 4. That looks like option A. Let me make sure 10 is A. 10, yeah, 10 is A. 10 is A. All right, got 10 is A. All right, you guys ready for 11? Right, number 11. If x squared plus y squared equals c, let's pause right there. What shape is that on a graph? Circle. Ah, circle with a radius of square root of c. Okay, so we got a circle and we got a negative xy equals b. What graph shape is that? That like an inverse relationship, like y equals negative 1 over x, something like that, right? Which is technically a hyperbola, but so like in physics, I would call it like an inverse relationship between x and y. Right? Okay, which of the following is equivalent to c plus 2b? Okay, I think we can just solve that with c plus 2b, just substitution, right? So saying let's do c plus 2b. Now c I know is x squared plus y squared, so that subs in for c, plus 2 times, and then for b, that's negative xy. So that could look like that, right? Right. Oh, also, if you glance at the answer choices, you can kind of get an idea where we're supposed to go with this, right? Looks like something kind of factored. You guys think factored, right? So I'm gonna shuffle this around. X squared plus y squared minus 2xy. Maybe I could do like x squared minus 2xy plus y squared, right? Now that is some math that is wanting to be factored. So let's see, got an X and a Y I think I'm gonna have, and then I need negative in the middle. Maybe I should do minus minus, I think. Okay, let's try FOIL. I'm gonna use FOIL to check my work. Did I factor this correctly? X times X, X squared, bing. Minus XY, bing. Negative Y. It's positive Y squared, bing. Ah, it shakes out. Okay. I could also call this X minus Y, quantity squared. Okay. Is that an answer choice? I think that's option C. Is that right? Is that C? It's 11C. Yeah, 11 is C. 11 is C. Right. You guys getting these. Number 12. The volume of a cone. Hey, it's cone time. Volume of a cone is 12 cubic millimeters. What is the volume of a cone in cubic millimeters with a third of the radius but triple the height? Ooh, do you guys see a competing effect? A third of the radius is making it smaller, but triple the height's making it bigger. Who will win? So let's say either you know the volume of a cone, or maybe you reference it. Maybe you say, oh, hey, I know they gave it to me. All I have to do is look at the front there. Got some radius here. I got some height here. Right. Let's say the initial volume of the cone, say volume initial, was here. Let's walk through it. I want to walk you guys through back how to get the scan. Right. What's the area of that there circle? Pi r squared. So got a pi r squared, right? And then if I multiply by h, that would give me the volume of very simply a cylinder. But this is not a cylinder. It comes to a single point, which means I need to multiply by what? 1/3. Right. So now I'm back to a cone, or you could just looked it up on the front page. It's given to you. Right. And this comes out to 12 cubic millimeters. 12 cubic millimeters. Right. Now, one reason I really like this question is this is a skill that maybe you've picked up or gotten better at in this class, physics. Right. We're changing different variables by different factors. How does that affect something else? Right. I do this more with my AP students, but maybe you guys a little bit. We do sometimes, right? Right. So I'm getting a third of the radius, but 3 times the height. Ooh, maybe you can see which is going to be more important, which is going to affect the overall volume more. What, the radius or the height? What do you guys think? The radius, because it's getting squared. So that 1/3 is getting like double counted. It's squared, right? Let's pop this in. Actually, let's do this first mental math. I think you guys can figure out mental math, right? So then a third times 3. Guys, what is a third times 3? A third times 3 is a third, right? What is a third of the original 12? 4. The answer is 4. The answer is 4, right? I do want to write that out like more full-wise, right? Hopefully, maybe by this point, having sat in a physics class for so long, hopefully, maybe you could kind of pull that out mentally like we just did, right? But let's do this the long way. The new volume is 1/3 of pi, okay, and then got a third of the original radius squared, and then 3 times the height. So big skinny cone. This 1/3 squared I'll pull out in front. So that's a third being squared. This 3 on the h I'll pull out in front, right? And then everything else, so 1/3 pi r squared h I'll leave right there, so that it exactly matches the original volume. That feeds in right there, right? A third squared times 3, yeah, itself is a third. So this is like a third collectively. This whole bit was 12 cubic millimeters. Third of 12 is 4. There is like a better proof right now. Okay, right, 4. All right, which is option B, is 12B. Yeah, 12 is B. 12 is B. Okay, 12 is B. Okay, guys good? Are we good? Do good. We're 13. Oh, ooh, this one. Marcy, spending $42 on coffee each month. She buys special pods of coffee that cost $7 each. Recently, Marcy decided she wants to reduce the amount of coffee she drinks per month by 9 cups. Okay. All right. Going back to the pods, surprise, now you know the pods hold 4 cups of coffee at a time. Okay. What's an equation Marcy can use to determine how many dollars D she will save each month? Woo! Okay, so I'm seeing a lot of numbers floating around. It's $42 she was initially spending, $7 per pod, 4 cups per pod, and she wants to reduce by 9 cups per month. Woo, that's a lot of numbers floating around. Right? One of those numbers is completely extraneous. You never even need at all. Which number is a complete red herring? $42, right? They could have made that like $500 a month. Maybe she's a total caffeine addict. And it doesn't matter because all we're asking is how much will she save each month. We're interested in how much she's going to reduce that by. So you could make the initial spending amount any number, and it would, as long as it doesn't drop to a negative, right? Yeah, would lead to the same answer, right? Also, if you glance at their answer choices, notice kind of like some earlier questions, they don't actually want you to solve it. They just want to say, like, what's the setup? I'll tell you guys something else. I have no idea how they're getting these setups, but I know my own way to solve it. So I'm going to solve it my own way, and I'm going to rearrange it to get one of their answers. I can solve this with dimensional analysis. You guys remember railroad tracks in this class? Dimensional analysis? I'm going to say D equals, so the number of dollars saved per month equals, right? I'm going to set up some railroad tracks. Choo-choo. You guys set up some railroad tracks in your notes. And the kind of starting point is the fact that she wants to reduce her coffee intake by 9 cups per month. So 9 cups per month, right? Reduction, maybe tag a negative sign on it if you want to, okay? Right? So that's going to be, right? Now we need to somehow translate that into dollars, right? And this is the number of dollars is railroad tracks. Well, I know that there is 4 cups per every 1 pod. I know that each 1 pod costs $7. So $7, right? Right, guys? Dollars per month, okay? Which is exactly what we're looking for. Guess that. So I'm going to say D equals 9 times 7 divided by 4, right? And because sort of like that, because it looks like in their answer choices they got 9s and 7s and 4s floating all over the place. Right? So can I rearrange this so that it looks like one of those? Right? And the way you can do that is take this 4 and the 7 and invert it to the other side, make cross multiply, cross divide. So take 4 divided by 7 times D is equal to 9. Right? And that exactly matches answer choice A. Okay, so that's what they were looking for. Right? That one was pretty tricky. So number 13 is A. You guys got number 13 is A? Right? 13 is A. All right. Number 14. At a juice bar, S servings of banana smoothie are made by adding B bananas to a blender. If S, number of smoothies, equals B, number of bananas minus 4, how many additional servings of banana smoothie can be made with each additional banana? Notice they're really emphasizing this additional, right? So it's like a continuous process, right? As we're adding bananas, we're getting smoothies, right? What's sort of that ratio, right? Right, guys, got it? Right. Maybe you get a part-time job and you're working at this banana smoothie place, right? And maybe you walk in the morning at like 6 o'clock, whatever, and maybe you have to load like at least 5 bananas just to get this blender to start working, right? So you pop in a bunch of bananas, right? And then the customers start rolling in. Let's say like there's 200 customers over like the course of a day, right? So, they're ordering smoothies. You keep popping in bananas. Jesse, this is kind of like y equals mx plus b. You guys see that? If you interpret it like that, what's the slope of that line? 1. You see every 1 banana you add in is going to correspond to 1 new smoothie. You see that? Right. Now, yeah, maybe you need a bunch of bananas to get it going in the first place. But once it's rolling, every 1 new banana is going to correspond to 1 new smoothie. Right? Maybe like 1 smoothie has an equivalent 1 banana. The answer is A. Number 14 is A. You guys got 14 is A? 14 is A. 15. We got g of x is 2 minus 3 to the power of x. Now that right there is an exponential function, which you hardly ever see in physics. Right? Physics, we have parabolas all over the place, but hardly ever do you see exponentials. Okay? What is the graph of negative g of x? And then they give you 4 graphs as options for answers. Right? So let's go ahead and graph this and just find the graph that looks like that. Right? So negative g of x is okay if I just make everything negative. So that'd be positive 3 to the x and then minus 2. See, I just negated that. Right? And that's what we're graphing. I call that f of x, and then we're just graphing that. Right? Right? You guys got that set up so far? What does this graph look like? Right? Again, having that variable in the exponent, not something you really ever see in this physics class, right? I don't know why I dashed that. Right? It's supposed to be a y-axis there. Okay. So you got x-axis, y-axis. There you go. Let's get some coordinates with that. Something like that. All right. Now what does that graph look like? Right. And if you don't know, then let's just start plotting some points. And I'm gonna do two different graphs. Let's start with purple ink right here. Right. I'm just gonna graph 3 to the x. Right. So if x is 0, then what does y equal to? What is 3 to the power of 0? 1. So at 0, y is 1. That is a point on the graph, y equals 3 to the x. Right? Let's plot a few points. What if x is equal to 1? What is 3 to the power of 1? 3. Bam. Let's plug in 2. What is 3 to the power of 2? 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's right there. Bam. Get that. Okay. Okay. What is 3 to the power of -1? Yeah, 1/3. It's 1/3. It's still positive, isn't it? Ooh. Okay, so it's like right here. What is 3 to the power of -2? 1/9. Right? And then you guys see what's happening is that to the left it's going to approach this horizontal asymptote in a hurry at y equals 0. Right? And then once you cross the y-axis, it takes off in a hurry. Right? That is exponential growth. Right? Exponential growth. You might see that in interest rates, right? If you like have a money collecting interest in some account, right? Take off real fast. Zoom. Economic growth, inflation. What else is exponential? Yeah, some population growth, right? Right. And until you reach like some limiting factor, right? Yeah, there could be parts of, right? Could be exponential. Right? No, forget something. I think later, like, I can't wait to forget. Right? But one more thing we need to do. Right? Let's go back to the original. We need to slide this down too. Or I was going to ask you guys. You guys would have said that though, right? We're going to slide this whole thing down too. Right. So that includes the horizontal asymptote. It's going to come down 2 points. New horizontal asymptote at this point, down 2. This point, down 2. This point, down 2. Right. Everything slides down 2. Right? And here in black ink, I got the answer to the question. Right. So let's find a multiple choice answer that looks like that curve right there. Right. That is -g of x, which is 3 to the x minus 2. Okay. Like that. Right. Oh, technology, Moore's law. Moore's law follows an exponential curve. That's what I was thinking too. Right. So what looks like that? And it looks like option D, number 15, D. Yeah, 15 is D. Okay. You guys get that? 15 is D. Okay. Now these last 5, you don't get multiple choice, so you have to come up with the answers from scratch. And you have to bubble in the answers. Okay. So 16. We're getting this set up. We got like a system of equations, has solution mn. What is the value of m? If you want to replace that with x and y, if that helps, you can do that. Same answer. Okay. So I'm going to solve this by substitution. 1/3 of 5m minus, and instead of n, I'll just call it 3m. Got a substitution right there. 31 1/3. Okay. Right, good so far with that setup. Okay. And notice that I did the substitution in such a way that I can solve for m. Right, I substituted out the n. You guys get that? There's 2m. There's 31. So m is 31 on 2. Okay. So they're accepting 2 answers on this. You can do 3, 1/2, or you can do 15.5. Right. So you would write one or the other of those, and then you have to go through and bubble all the bubbles. So there's like slash bubbles, there's decimal bubbles in addition to the number bubbles. Okay, so either one of those. You guys got one of those, hopefully. All right, you guys get there? All right, number 17. Asaf plans to start working out at a gym. gym membership costs $50 per month, but he also has to pay a $30 one-time registration fee. Ah, you guys see y equals mx plus b getting set up right here, right? Slope of 50, y-intercept of 30. Right? Asaf wants to spend no more than $555 for the membership and registration fee. Okay, so he's on a budget. Right? He keeps going to this gym. He's eventually going to run out of money. The gym memberships are only available for a whole number of months. What is the total? Sorry, what is the maximum number of months he can work? Or sorry, he can go to the gym, have his gym membership. Right? So even if you got a decimal answer, you're always going to round which way, up or down? Down, right? For example, suppose you ran the numbers, you got like, 7.9 months. That means you really attend the gym with 7 months, right? Because you always round down, right? Maybe a little bit of money left over. So I'm going to say kind of like y, maybe I'll because inequality. How about that? Mx plus b kind of deal, right? Use that as a model, right? So he can go up to $555. He's going to be limited by that, so I'll use that type inequality. Okay. He's got $50 per month for some number of months. Maybe I'll do t for the number of months, like time, right? In months. Okay. Then plus the $30, right? Right? So as long as this expression is less than 555, he's okay. You keep going to the gym. Right? Right. So maybe subtract 30 over. That's like 525 greater than or equal to 50t. Divide both sides by 10. Maybe you do this a little bit different than I'm doing it. That's okay. Okay. As long as you got the right answer. I might do something like this myself. Frame it. Right. Okay. Guys, how many times does 5 go into 52? Yeah, 10 and change, right? Right. So you're gonna write what number is your answer? 10 months. When he's been going to the gym for 10 months, then at that point he has a little bit of money left over, but not enough for the next month. Okay. All right, so like 10 and change. So 10, the answer is 10. 18, 3 intersecting lines. Ooh, what's the value of C? Integrate. No, 2 principles you need to solve this. One is that, ooh, do you guys see a triangle in the middle? Triangle? All 3 angles of a triangle always add up to what? 180, so 180 degrees. Here's the other fact you need is 2 supplementary angles. So like along a straight line, always add up to also 180, right? So let's start walking through this. Guys, what is this angle right here? 83 degrees, right? Because this 83 plus this 97 would bring you up to a straight line 180, right? So I know this is 83 degrees, right? Right. Now here's where you can actually take a shortcut to the answer. You guys ready for this? Right. This 83 plus this 34. Let me jot that down. Right. We need this 83 plus this 34. 83 plus 34. Is that 117, I think? Whoops. There you go. 117, you guys think? So I know that these 2 angles collectively make 117, right? So this third angle, could you do 180 minus 117? And that'll give you something. But then whatever C is, well, that's just 180 minus that. So do you guys see what we're doing? Like we're doing back-to-back steps of 180 minus something, right? Right. Right. So guess what C always has to be? It's the sum of these 2 angles, which in this case is 117. Okay. Okay. So here, you could have done the extra step. I know this is a no calculator section, but I'm just gonna demonstrate this. You could say this angle right here is whatever 180 minus this collective 117 is, which happens to be 63 degrees. Maybe you did that. Maybe you did that middle step. You got 63 degrees. But then you're just going to do 180 minus that. And that just brings you back to 117 anyway. Okay. All right. A little shortcut you can take. Number 19. Oh, ooh, we got algebra expression. What is the value of S for solution? I'm going to change that to X. Just so it doesn't look like a 5 and then go, well, what's a 5? What's R? Right. X. Right. Guys, okay with that? Set up. Right. Distribute. 9x minus 18 plus 3x plus 6 is 7x. I have 5 terms. 3 of them have the x, 2 of them don't. Let's just get like terms together. 9x plus 3x minus 7x equals 18 minus 6. Right, you guys good there? I get 12 minus that's 5x. Is that 5x? Is equal to, is that 12? Right. So x could be 12 over 5. Right. Now, this one, you have no multiple choice. You have to write and bubble in an answer. They're accepting two answers on this. You can do 12/5, or 5 and 5 is 10, 2 over 5 is 0.4, 2.4. Right. So if you wrote either one of those, again, slashes and decimals are bubbleable, right? So those are opposite, right, in addition to the numbers. Either one of those, right? You guys got it? All right, so we did 19 out of 20. Bells about ring. So number 20 we'll do tomorrow, and then we'll start on section 4 and get as far as we can to the weekend. Oh yeah, math.